Alright, so we're about to work on my favorite part of this chapter, in this section, 4.3, is the properties of logarithms, because this is where we, I don't know why I like it actually, it's fun. I think it's fun. I hope that you will take the approach of trying to have fun with it, because it's just like working out a puzzle, it's all about strategy and it's fun. So we've got a toolbox of properties that apply for logarithms, and one of them, the first one, is the product property. And it is that if you have a log of some kind of base, and the argument is a product, you can rewrite that as the sum of two separate logarithms, one for each factor. So let's test it out and see if it works, shall we? How about if we had log base 2 and the argument was 32? And we wanted to see, we're going to see if we rewrite this. Let's just test out this theory that you can write it as a sum of two logs. Let's see, the products here could be 4 times 8, right? And then we would have the log base 2 of 4 plus the log base 2 of 8. All right, so we're going to test it out and see if it works. So first we'll just evaluate the log base 2 of 32. And remember, a logarithm is the exponent you would need to raise the base to in order to get the argument. So if I rewrite this in exponential form, it would be 2 to some power is equal to 32. So if you raise 2 to the power of 5, you'll get 32. Therefore, this whole expression here is equal to 5. So I'm going to write 5 equals, and then we're going to evaluate these two pieces and rewrite them here and see if it adds up to 5. Alright, so this one first. 2 to some power equals 4. Well, we know what that is. That's 2. And 2 to some power equals 8. Well, that would be 3. And what do you know? 2 plus 3 does equal 5. Awesome. So let's then go on to another example. All right, so actually we'll not do another example. We'll just say, okay, we found one example that works. I think I believe the property. So the product property works. What other properties do we have? We have the quotient property. Oh, that sounds good. Let's take a look at that. The quotient property is, well, what is a quotient? Well, just like the product is a result of a multiplication of two factors, a quotient is the result of dividing. So, our quotient property is that the log of some base with an argument that is the quotient of two numbers can be rewritten as two separate logs. This time we're subtracting them though. So that would be x and y. Okay, should we try? Or do you just want to believe me? You just want to believe me, right? Okay, and then what else? We have the power property. The power property is when you have the log of some base, and then the argument actually has an exponent on it. Well, when that happens, you can rewrite this with the exponent being multiplied in front of the logarithm, like that. And that can be really useful. And also a couple of other properties that are very important to keep in mind is that the log of some base with the argument of 1 will always equal 0. And that makes sense to us, right? Because a to the power of 0 is always 1. If you rewrite that in exponential form, no matter what the base is, if you raise it to the power of 0, you do get 1. So that makes sense. And what else? The log... Whoopsie. Something's happening. The log base a of a. Okay, so when your base and your argument are the same value, what happens? What do you think it's going to be equal to? You want to try to guess? Well, if you rewrite this in exponential form, that'll be a to the power of something equals a. Yep, you're right. It's 1. A to the power, or log base a of itself is 1. So those are our properties that we're going to be using in order to answer some questions. But we're going to start off with just rewriting logarithms using those properties. And, well, actually, I want to do one like this with letters in it. So the log base a of the quotient, which has a product in the top and a product with powers in the bottom. This one is like the most complex example you could possibly get, which is why I chose it, because it's so much fun. So first of all, I'm going to apply the quotient rule. So I'm going to look at this as the top and this is the bottom. So I'm going to rewrite this as the difference of 2 logs of base a, with the numerator first and the denominator second. And then we can expand this even more. We can do, that is the log base a of m plus the log base a of n plus the log base a of q. Okay, so that was all that first expression, and then minus, now here you want to be careful because we're subtracting and it's going to be a sum because we've got a product in here. So I got to make sure to be careful with that negative because it does need to be distributed after I have expanded this part of it. Okay, so then I have the log base a of p squared plus the log base a of t to the 4th power. And I can distribute that negative. I'm just rewriting everything. And then the log, oh, okay. I'm going to distribute the negative. Yeah, I'm going to do that. But I'm also going to move this exponent in front of this log so that it's 2 log a with the 2 times the log base a of p, and then the negative also gets distributed to this part. So I have negative, and then I also want to move this in front for log base a of t. Alright, so if you could handle that, you're alright. You can handle anything. But let's look at a few more examples that are maybe not quite so involved. How about, let me see, what do we have here that we can do? It's going to be so fun, guys. I'm going to choose a really fun one. Number 63 from the back of the book, log base 2 of 6x over y, so that's my argument right there, is log base 2 of 6x minus log base 2 of y. And this one can be rewritten as log base 2 of 6 plus log base 2 of x, and then bring down the minus log base 2 of y. And we can probably simplify that a little further with this part, but I don't want to because it's not a clean number. It's going to be some kind of approximation. So we'll leave it in exact form. So that'll be our final answer. Yay! Let's go on and do another one. That was fun, right? Let's do 65. The log base 5 of 5 times the square root of 7 over 3. Okay, so that's the log argument. So that'll be the log base 5 of 5 square roots of 7 minus the log base 5 of 3. And then this can be expanded. So I'm going to make it the log base 5 of 5 plus the log base 5 of root 7 minus the log base 5 of 3. And this can actually be rewritten as 7 to the 1/2 power. And then this can be simplified to 1. The 1/2 can come in front of that. And I think that is expanded and simplified as far as it can be. So we'll move on and do another one. Wasn't that fun? So fun. Number 67. Log base 4 of 2x plus 5y. Okay. You might be tempted to try to do this. Something like that. I've seen a lot of people do that. It doesn't work that way. It does not work that way. They have to be two separate logs, and this is not two separate logs. And you can't distribute a log. This part of it, you cannot like go and make this the log base 4 of 2x plus the log base 4 of 5y. You cannot do that. It doesn't work like that. I could explain why, but I'm not going to. Maybe I will in another video if anybody wants to know, but I'm going to try to keep it focused on solving, just showing you the solutions rather than going into depth about the reasons behind it. But that's because when I do try to explain things, a lot of times it gets too complicated and the student ends up feeling more lost than before. But if you do want me to explain, let me know and I'll do a video on it just about that. So we cannot distribute this log expression. We cannot condense this into a product. It's not the right form. And there's actually not much, we can't do anything with this, actually. There's no way to simplify this. It is what it is. And that would be your answer. Your answer would be, this cannot be simplified. Sorry. It is already as simplified as it's going to get. How about 71? 71 is log base 2 of AB over CD. So I would make that log base 2 of AB minus log base 2 of CD. And then log base 2, I'm doing this part, rewriting this part using the product rule, log base 2 of A plus log base 2 of B, and then I'm going to make this into a sum, and I know that I'm going to have to distribute the negative, and so I'm going to end up with two minuses. So the log base 2 of C minus the log base 2 of D. Actually, I better show that intermediate step so that nobody gets confused. So what I would have done first is leave that negative out front, expand log base 2 plus log base 2 of D, and then distribute the negative in the next step. So my final answer is that. See, these things are fun. I never told you what the directions were on problems like these, so maybe I should do that. Maybe I should tell you what the actual directions are. The directions would be, use the properties of logarithms to rewrite each expression. So when you see these directions, this is what you're supposed to do. Okay, you're supposed to know that that means to expand them. And so we've been expanding logarithms into sums and differences. And now we're going to go the opposite direction. We're going to take expanded logarithms and condense them back into a single logarithm. So I'm going to show you number 75, and I guess I'll write the directions first. Write each expression as a single logarithm. Write each expression as a single logarithm. Okay. It also says assume all variables represent positive real numbers. Okay, fine. And then number 75 says log base a of x plus log base a of y minus log base a of n. So we're going to condense that. Since they all have the same base, we can do this. Let's do these two first. We'll condense that using the product rule in reverse. And then bring down the minus log base a of m. And then we will condense this now. So we have the log base a of xy divided by m. Okay, and that's our answer. And now, what else? Let's do 77. Log base a of m minus log base a of n minus log base a of t. And at any point that I'm doing examples, it's a great idea to pause the video and try to see if you can do it on your own, and then you can just start it up again to see if you were right. That's a much better way of studying than just to watch and watch and watch. Okay, so log, well, they are all the same base. That's good. So I can probably, yeah, I can use the quotient rule here. And then bring down that other log, and we'll use the quotient rule again. The log base a of m over n over t. And I'm going to want to simplify that. I don't like the way that looks at all. So keep in mind that when you have m over n divided by t over 1, you can rewrite that as m over n times 1 over t. Remember, change, flip, keep the first fraction, change the sign to multiply, and flip the second fraction, and then you multiply straight across, so you get m over nt. So my final answer here is log base a of m over n times t. That was number 77. See, they're fun, right? Aren't they so much fun? Let's look at number 81. This one's a doozy. 2 times the log base a of z plus 1 quantity, and then plus the log base a of quantity 3z plus 2. Alright, so let's see what we can do. Well, first of all, this can become an exponent right here. And I'll rewrite the second logarithm. And then we've got 2 logs of the same base being added, so what we can do is condense this into a product of their arguments. So a single log of the product of the two arguments. What do you think of that? Pretty cool, right? Want to do one more? Let's do one more. Let's do... Yeah, I don't want to do any more. I think that's enough, right? Let's see. Use the given. What else should I do with you guys? Oh, I love these problems, but I'm going to start in a new video. So I hope you enjoyed that. And please let me know if you'd like me to do more or if you have any questions. Take care.